Hello, so now that the meeting is now being recorded, hello, good morning again everybody. Welcome again to Principles of Steel Design. So for today's meeting, I would just be discussing simple bolted connection. But confirmation first everyone, do you see my laser pointer?
Yes,
Yes,
sir.
sir.
Okay, so very good. So what you are seeing in this slide right here is actually different types, different methods of connecting your steel structure. So we have here on our upper left, the rivet connection, we have here bolted connections, and we have here welded connections. And as for these welded connections right here, I have already posted a pre-recorded video lecture about how to analyze and how to design welded connections in steel design. So once again, our topic for this meeting is to be about simple bolted connection. But what is a simple connection? So as per the definition here, by the way guys, confirmation, readable ba itong nasa slide na to? Nababasa ba siya?
Yes, sir.
Okay, so as per stated here, if the line of action of the force acting on the connection passes through the center of gravity of the connection, then it is assumed that each bolt resists an equal share of the load. So meaning the strength of the simple connection will be equal to the sum of the strengths of the individual bolts in the connection. So this is fairly self-explanatory, no? Sinabi dito na if we would be having our loads right here, if it acts concurrent with the centroid of your bolt. So, wait, confirmation first. Do you see the dots here? May blue dots ako linagay dito. Kita ba siya, guys?
Yes, sir.
Okay, so, yan. So, assuming that these are to be your bolts, so let's say kapag kukunin niyo yung centroid niya, it would be about this location right here. So it is said that if your force PU or PA acts concurrent with this point right here, it is then called a simple connection. So kapag yung force natin is nag-act sa centroid ng iyong connection, once again, simple connection siya. And the idea behind your simple connection is that all of these bolts right here carry the same amount of load, which is PU or PA divided by the number of bolts. So drawing lang tayo sandali. So suppose that this is to be your resisting forces. So sorry for the drawing. Hirap mag-draw digitally eh. Okay, so this one right here. So if your connection is to be a simple one, it is assumed that all of them carry the same amount of load, which is PU over, kung ilang man volts yan, so PU over 6, PU over 6. So pare-pareha silang lahat. So may that be PU or PA. And as you can see in this last line right here, the strength of the simple connection will be equal to the sum of the strengths of the individual bolts in the connection. So meaning PU over 6 times the number of bolts, which is 6. So PU over 6 times 6. So yung strength daw neto is to be equal to PU or PA, whichever the case may be. Are you guys following?
Yes, sir.
How about for the others? Okay naman?
Yes,
po, sir.
Okay, so ayan.
Okay naman, sir.
Yan, very good. So yan, ganyan lang kasimple yung ating simple connections. So, okay, there are to be two ways a bolted connection resists loads. So, it may either be by bearing and shear or by friction. And namely, they are to be called bearing type connection and slip critical connection. So, let's go straight to bearing type connection first. So, in your bearing type connection, it is assumed that the loads, so let's say that these are to be your loads, but before I proceed, guys, nakikita ba tong mga labels na to? Is it visible?
Yes, sir.
So, VPN naman nakikita nyo guys. Ito, VPN naman.
Opo, sir.
Yes po, sir.
Okay, so this
Yes, sir.
very good. So this VPN right here indicates that the designer here uses LRFD kasi nga VPN. Okay, so moreover, ulitin ko lang, it is assumed that the loads here are to be resisted by the contact area between the steel bolts and the surface of the member itself. So if I would be zooming this in, so zoom in ko lang sandali para, of course, lumaki. So as you can see here, there is to be a contact point or contact area here. So ito yung sa member, then this is to be for the bolt. And contact pressure is basically your bearing. So, bearing. So, you have learned this in your mechanics of deformable bodies or yung strength design na tinatawag natin. Strength design, strength of materials. So, that is for bearing type connection. So, paliitin ko lang ulit para mas maayos yung ating lesson. So, ayan. So, that is for bearing type connection once again. So, moving forward to slip critical connection. So, in here, it is assumed that the loads are to be resisted by friction. So, as you can see here, we have force F right here. Kita ba yung force F, guys?
Yes, sir.
Okay, so it is stated here that this force F right here is actually the resisting force of your slip critical connection. And from your statics of rigid bodies, it is said there that when two bodies are in contact with each other, there is to be the presence of friction. So as you can see, this member right here on the top is having a connection with this bottom member right here. Thus, we would be having a certain friction in this part of your member right here. So dito sa gitna, no, may friction yan. Unless stated otherwise. So unless wala tayong coefficient of friction sa part na yan. So, kunyari, sobrang dulas ng part na yan, it is then that we would be disregarding friction or kapag hindi masyadong malaki yung normal force. Because once again, from your static of rigid bodies, your friction force F, so basically yung ating friction force, di ba palagi nating sinasabing small letter F yan, it's just that kaya ko ginawang capital F dito, it's because that in this figure, capital F ginamit niya. But that may be capital F or small letter f. Anyway, from your statics of rigid bodies, once again, your friction force F is equal to mu times N. And your mu is to be the coefficient of your static friction, and your N is to be your normal force. Are you guys still following?
Yes, sir.
Yes, sir.
Okay, so ayan. So it is said here that the force F or your friction F is equal to mu times normal force. And your normal force is actually the force that is perpendicular to the line of action. So in Tagalog, teka, mahirap pala Tagalogin yun. Wag na lang. So suppose that this is to be your system. So let's say that your line of action is to be horizontal. So it is to be in this manner right here. Your normal force is to be the one that is perpendicular to this line of action right here. Naintindihan naman, no, guys? Basic?
Yes, sir.
Yes, sir.
Okay, so ayan. So if this is to be your equation, the greater the normal force is, the greater the friction force. So in Tagalog, kapag mas mahigpit ang ating bolts, mas malaki yung naitutulong ng friction. So in English, the tighter the bolts, the greater the friction force F. So there. And let's say that this force F right here, so if let's say your force F is greater than the design load, so let's say phi Pn, or let's say F is greater than your Pn over omega, so ASD LRFD, it is in this case that we can conclude that our system is to be a slip resistant connection. So, slip resistant connection. So, ano kasi yan, no? Kapag mas malaki nga yung ating friction force kaysa sa ating VPN, of course, hindi siya dudulas. Thus, it would be slip resistant kasi nga hindi siya dudulas. Are you guys getting my point?
Opo, sir.
Yes, sir.
Okay, about for
Yes,
the
sir.
others. Yeah, very good. Okay, so going back to bearing type connections, no? So even though that this material right here on the top is in contact with the material at the bottom part, we are to neglect friction here. It is because that the bolts here, so these bolts right here, are only tightened to the point na yung tinatawag nating, you call that snug tight condition. So snug tight condition. Teka, ilipat ko lang. Baka hindi nyo na napabasa eh. Okay, so snug tight condition. And this snug tight condition is, well, the tightness of your snug tight condition is attained by the effort of a person using spud wrench only. So kapag yung inyong mga construction worker, riniwrench nila ito and medyo humigpit na, so okay na yon, tama na. Unlike in your sleep critical connection wherein it would be tight already, they would still tighten it further. So kapag kahit mahigpit na, hihigpitan pa nila lalo up until the point that the stress of this bolt right here would reach its 70% of its tensile stress. So for your bearing type connection, these bolts right here are only tightened to what we would be calling snug tight condition. So it would just be that. As for your sleep critical connection, it would go further than your snug tight condition. So let's say that it would be tight already. They would still be tightening it up until it would reach 70% of the tensile load of your bolts. Am I making myself clear, guys?
Yes, sir.
Yes, sir.
Okay,
Yes,
very good.
sir.
So these are to be the following ways on how loads transfer and the types of joint. So this one right here is what you would be calling your lap joint. By the way, guys, are these text readable?
Yes, sir.
Okay, so there. So eto, in your lap joints, it is, well, in this setting right here. And these are just two members overlapping in this manner. Teka, palakin ko na lang para sure nakita ng lahat. So there. So as you can see here, this member right here is overlapping this one right here, and it is connected by a bolt here. Bolt nga pala yung topic natin. So ito, so it is connected by a bolt here. So suppose that this is to be your load P, and this is also to be your load P. It is then transferred to this surface right here via contact pressure, which is what we would be calling bearing. Then as for this one right here, dito sa right, it is to be this one right here. So it would look like this. So ito yung bearing sa bolt na sa portion sa taas by your force P. Then this is to be the bearing on the lower part given by this force P right here. And its shear would be taken along the center part of this connection right here. So dahil nga naghihilaan yung ating upper and lower parts, this one right here or this surface right here is to be subjected with a shear stress. Are you guys following?
Yes, sir.
Yes, sir.
Okay, very good. So ayan. But by the way, guys, we have a catch here. So if your connection is just to be a lap joint, bending is to be produced in the lap joint. So bakit ganun yung case? So as you can see, the centroid of this bolt right here is to be located at this particular point right here. And the line of action of your force P is to be in this point right here. And the line of action of your force P at the bottom part is to be in this line here. So as you can see, we would be having the presence of an eccentricity. So if this is to be your centroid, we would be having an eccentricity here about this point. Nakikita ba, guys? Yung dinodrawing ko?
Yes, sir.
Okay, so we would be having a lever arm here or an eccentricity. And as you know already, if there is the presence of a force and an eccentricity, there would be a resulting moment. So magkakaroon ng moment about that point. And moment would also result to bending. So that's why this part right here has bent. So nagbend siya, it's because of the eccentricity. Are you guys following?
Yes, sir. Yes, sir.
Naintindihan naman po.
Yes po, sir.
Okay, so very good. So next tayo. Erase ko lang sandali. Ba't ko pa erase? So next na lang tayo. So once again, the one earlier is what you would be calling a lap joint, and this one right here is your butt joint. So buttjoints. So as you can see here, we have two shear areas or two shear planes. Palakin ko lang ulit para mas makita nyo. So there we go. Guys, are the text readable?
Yes, sir.
Okay, so as you can see here, unlike in the previous part when we have just one shear plane area, this time we would be having at least two shear plane areas. So at least two. So at least two. But take note here, guys, that if this is to be your force P, each of this member right here would carry P over 2. to attain equilibrium. So if we are to get the stresses here, so for the bearing stress, so dito sa part na to, it would be this one right here, which is the load, which is P over 2, divided by the contact area. And that is to be your bearing pressure. And as for the bearing pressure at this point right here, same, P over 2 divided by the bearing area. So that is to be this one right here. But for the bearing at the middle part, which is this part right here, it is to be equal to your load P. So this is to be your load P divided by the contact area or the bearing area. And that is to be equal to this one right here. So as you can see, guys, that this is to be in this direction and this one right here is to be in this direction. There is once again to be the presence of shear stress at this point right here and shear stress at this point right here. So it would be this one right here and this one right here. But nawala ang ating Google Meet. Okay, so by the way, guys, can you still see my laser pointer here?
Yes, sir.
Confirmation. Can you still see a calculator below me?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so ayan. Chinek ko lang para nag-error kasi. Okay, so once again, you might have heard this line from me a lot of times already that whenever you are to design or analyze a certain structural member or a certain structural component, we must first take into consideration the manner in which that certain structural component will fail. And after knowing the manner of failure, you must design the system for it to resist the failure that you have anticipated. So ito yung ating mga failures for our bolted connection. So for this first one, this is what you would be calling your single shear failure. So bakit single shear? So self-explanatory, we only have one shear plane here. So ito yung shear plane niya, napunit siya. So this is to be a single shear failure. And as for this one on your right, this is what we would be calling our tensile rupture. Well, tensile rupture. And yung sinosolve natin dito is yung tensile rupture stress. So we already have talked about this last midterms. Last prelims and midterms pala, short term nga pala to. So this is to be one of our first topics, which is the tensile rupture stress. And as for this one right here, as you can see, medyo nag-move na siya, no? And this is to be your bearing failure. Confirmation, guys? Yung sinusulat ko ba readable?
Yes, sir.
Yes,
Okay, so thank you.
Yes, sir.
Okay, so very good. Very good sa akin. Ang galing. Anyway, so dito sa letter D, this is what we would be calling shear failure of the plate. So this is to be your shear failure. So shear failure of the plate. By the way, guys, this one on top is to be a single shear failure of the bolt. So ito, shear failure of the plate. And this one right here is to be failure of the bolt. And lastly, this one right here at the bottom part is what we would be calling double shear failure of the bolt. So why is it called double shear? So sulat ko lang ulit. Double shear failure. So there. So bakit siya double shear failure? So self-explanatory because as you can see here, we have two shear planes that have failed, which is this part right here and this part right here. So am I making myself clear, guys?
Yes, sir.
Yes, sir.
Okay, very good. Okay, sige. Mag-proceed na tayo. So if there are no more questions, let's proceed. So these are to be the parameters that we will be using in our design and the analysis of our bolted connection. So in page 405 of your structural steel design book by Jack McCormack, you would be seeing these parameters right here. So we have this figure and we have this table right here. So from this figure, it is said here that this dimension right here or your P here is to be your pitch. And this letter G right here is to be your gauge. And these parameters right here was already introduced to you last midterms when we have talked about block shear Tama ba? So, oo, tama yun. And in your wide flange, your G or your gauge G is to be these parameters right here. So, eto. And kapag angle, eto yung pitch and eto yung gauge. And once again, the values of it was already introduced to you last midterms prelims. Basta yung ating unang mga topics which was about block shear. So there. And this table right here is to be the minimum edge distance from center of standard hole to the edge of connected part. And they are to be dependent upon the bolt diameter that you are analyzing. So suppose that in your system, so suppose that this is to be your connection, you are to use 16 bolts, which is this one right here. So the minimum edge distance from the center of the bolt to the, well, the edge of your member is to be 22 So what that means is that from this point right here, so sa center ng inyong bolt up until the edge, so the minimum distance of this is to be 22 So this should be greater than or equal to 22 So if you would be using 36 bolts, the minimum edge distance from the center of the bolt to the, of course, the edge is to be 46 So, kuha naman guys. Are you still understanding? Diyan pa kayo? Buhay pa? Gising pa?
Yes, sir.
Okay. Yan, very good. Okay, yun lang naman, no? So, if we have here your minimum edge distances, we also have our maximum edge distances. And as stated in this part right here, but confirmation first everyone, readable ba itong mga to?
Yes po, sir.
Okay.
Yes, sir.
Okay, so very good. So as stated here, the maximum edge distance should not exceed 12 times the thickness of the connected part or 150 whichever is smaller. So 150 or yung 12 times ng ating thickness ng connected part. So for example, no, yung dito sa part na to, yung thickness natin ng angle is to be, let's say, 10 So meaning, the maximum edge distance is either 10 times 12 or 150 And 10 times 12 is equal to 120 So 120 So comparing it with 150 well, it is common sense that this one right here governs. So ito yung mas maliit kasi na value. So yan, easy peasy lemon squeezy. And for this second one right here, the maximum spacing of connectors for painted members or unpainted members not subject to corrosion is to be less than or equal to 24 times thickness and 300 So ito no sinabi dito for painted members or unpainted members not subject to corrosion. And in Tagalog, your corrosion is yung pangangalawang. So in Tagalog once again, kapag pinturado ang inyong mga members or let's say na hindi subject sa corrosion ng inyong mga members, these are to be your maximum spacing. So, of connectors to, no? So, the maximum spacing of this one right here is to be from this center right here up until this center. So, hindi siya edge distance. So, there. And for unpainted members off weathering still subject to atmospheric corrosion or yung mga critical sa kalawang na ating mga bakal, that is to be less than or equal to 14 times thickness or less than or equal to 175 whichever is smaller. Okay guys, buhay pa? Okay naman?
Yes, sir.
Okay, very good. How about for the others?
Okay naman, sir.
Okay, very good. So, sige, proceed na tayo. So, aside from this, you also need to know this one right here. And as I know you are already familiar with this table right here from your analysis of tension members. So, these are to be your standard diameters if you would be using these bolt diameters right here. So, before kasi, ang ginamit nyo pa lang is to be your standard diameters. Then, meron na akong isang seatwork na gumamit din kayo ng oversized diameters. But these are to be it. So, if you can remember, if you would be using 16 the nominal diameter of the hole, if you are to consider standard diameters, is to be equal to 18 So, saan ba ginagamit itong standard diameter, oversized diameter, short slot, and long slot? So, for your standard diameter, these are to be used for both bearing type, so bearing, and snug tight. So that is for your standard diameter. And for your oversized diameter, so this is only used for snug tight. Ay, snug tight, mali pala, hindi pala snug tight. Bearing or slip critical. So bearing or slip critical, I should say, not snug tight. And for your oversized diameter, this is only used for slip critical connection. So hindi siya pwede for bearing type, no? So why is that the case? Because in your oversized diameter, as by the name itself says, yung diameter ng ating butas, which is, well, this one right here. So if you would be looking to your right, meron akong drawingan dun na butas, which is this one right here. So this hole right here is oversized, as the name itself states. So kapag babalik tayo dito, no, mas malaki ang ating bolt diameter kapag oversized. Meaning that our, our bolts are not in contact with your members. May space siya, no? As you can see by this blue shade right here. Nakita nyo ba guys yung dinodrawing kong blue?
Yes, sir.
Okay, so yan. So as you can see, meron siyang space. So meaning, we cannot use it for bearing type connection. So pang slip critical connection lang ang ating oversized bolt or oversized diameter of the bolt that is stated in this column right here. And by the way guys, what is this short slot or long slot right here? So basically, it is to be this one right here. Kung nakakita na kayo ng ganitong butas sa mga steel members, so ito siya. So the difference between a short slot and a long slot is, well, self-explanatory, is that your long slot is longer than that of your short slot. So as you can see here, if this is to be 18 by 22 for your short slot, for your long slot, that is to be 18 by 40. So same is true with this one right here. So 33 by 40 for your short slot. And for your long slot, you would be using 33 by 75. So yun lang. And when can you use your short slot and your long slot? So you can either use it for your bearing type connection or your slip critical. So same is true with both. But make sure that if you would be using these slots right here for bearing type connection, make sure that the length of your slot is to be perpendicular with your line of action. Ewan ko kung naintindihan nyo yun, mag-drawing na lang tayo. So suppose that this one right here is to be your bolt. Confirmation for first everyone. Can you see what I am drawing on your right?
Yes, sir.
Okay,
Yes, sir.
so ayan. So suppose that this is to be your bolt. So let's say that your line of action or the force P is to be acting in this direction right here. Teka, ilibahin natin ang ating color. So itong green. So let's say that this is to be your force P. So P. So we can only use snug tight connection in this manner. Kasi as you can see, wala namang contact surface dito sa paligid na to. But let's say that the force that would be acting upon this connection right here is to be in this manner. So it is here where you can use bearing type connection or your slip critical connection. As you can see, may contact surface tayo dito sa portion na to. So meron tayong bearing dito sa part na to. So we can use bearing type connection. So am I making myself clear, guys? Naintindihan naman? Formulate
Yes,
niyo
sir.
question. How about for the others? Are there questions or naintindihan naman? Oh, Mr. Querido.
Naintindihan naman po.
Okay. Very good, Mr. Sisu. Mr. Querido.
Yes, sir. Naintindihan naman po.
Okay, very good. Miss Kalob.
Naintindihan po, sir.
Okay, very good. Miss Omanito.
Okay naman po, sir.
Okay, sige. Mag-proceed na tayo if that is to be the case. So yan, ito lang yung mga butas na ginagamit natin for our steel structure. Moving forward, this is to be the table or the strengths of the fasteners and the threaded parts for your bolts. So as you can see here, we have two tables indicated here. So this table right here is from the book of Jack McCormack, and this table right here came from the book of the National Structural Code of the Philippines, 2015. And as you can see, we have a little bit of a discrepancy here. So as you can see here, ang strength down ng A307 bolt is to be 188. So this is to be 188. But by NSCP, it is stated here that the shear stress of your A307 bolts is to be 165 MPa. So ano ba yung susundan natin dito sa dalawa? So we would be following this table right here since this is to be our national code. And as you can see, using this parameter right here is to be more conservative to use yung 165. So that is just to be its difference. So yan, kalimutan na muna natin itong nasa left and let's use this table right here. And by the way guys, this A307 bolts right here is what you would be calling your common bolts. I mean common strength bolts. So common bolts. And it is sometimes referred to as unfinished bolts. So unfinished, hindi natapos. Teka, i-move ko lang pababa at mukhang di nyo na nakikita ang aking pinagsusulat. So there, so unfinished bolt. And as for this ones right here, so these are to be called your high strength bolt. So HS bolt. So self-explanatory why it is called high strength kasi mas mataas yung strength niya, no? As you can see, doble. So the strength, I mean the tensile strength of your A307 bolt is to be 310 and the nominal tensile strength of your A325 bolts is to be 620 and as for your 490 that is to be 780 megapascal. So ayun, yun lang naman yun. So proceeding. So these are to be the equations that we would be using for us to determine the bearing strength of a connection. So let's say that if deformation around bolt holes is a design consideration, we would be using this formula right here. But if not, gamitin naman natin to. So what does this mean? So suppose that in your connection, you don't want to have a deformation greater than 8 mm. So let's say 8 mm. So kumbaga ito yung maximum natin na deformation. So kapag 8 mm and below ang ating deformation, we would be using this formula right here. But if it would be greater than 8 mm, so kunwari wala kang pake kung mag-deform man yung butas mo, gagamitin nyo naman ito. So that's if, once again, the deformation around bolt holes is not a design consideration. So once again, kapag okay lang sa inyo na lumagpas ng 8 mm yung kanyang deformation, gamitin nyo to. So both of these formulas right here are applicable for standard diameters, standard diameter bolts, oversized bolts, and what do you call that? Yung slotted holes natin, which is yung short slotted. So short slotted holes. And we will be using this formula right here for long slotted holes. So, ayun lang naman. But make sure that the slots are to be perpendicular to the forces, just like what I have said earlier in this case right here. So, hindi mo pwedeng gamitin as a bearing type connection if your force is to be in this manner. So, dapat ganito lang yung force mo pag gagamitin mo yung slotted holes mo as bearing type connection. So, are you guys still following?
Kuha po, sir.
Okay, very good. Miss Maria Grinolin.
Apo po.
Okay.
Yes, sir. Okay po.
Okay, very good. Mr. Sisu, how about you? Questions?
Wala naman po, sir.
Okay, very good. Miss Gaano, how about you?
Ano naman po, sir?
Okay, sino pa ba may tanong guys? Miss Gonzales.
Wala po, sir.
Okay, very good. Miss Kalob, wala?
Wala po, sir.
Okay, so yan, proceed na tayo. So once again, these are to be the formulas that we would be using for us to determine the bearing strength of your members. Of your bolts, I should say. Okay, so anyway, so let's just have this example right here. So in this example, determine the design strength and the allowable strength for the bearing type connection shown. So this is this is to be our bearing type connection. So steel is to be of A36 specification and the bolts are 22 mm A325 specifications and the holes are standard sizes. So standard sized bolt yung gagamit. Standard sized bolt yung bolt hole. I should say. Ulit, the holes are to be standard size. So standard size holes yung gagamitin natin dito. And the threads are excluded from the shear plane and we are to assume that deformation at bolt holes are a design consideration. So as you can see here, sabi dito, design consideration daw yung deformation. So meaning we would be using this formula right here at the top. So ito. And as you can see here, it is said here that the threads are excluded from the shear plane. So if you would be going back to this table right here, meron kasi tayo dito yung tinatawag, no? So etong row na to is to be used if the threads are not excluded from shear plane. And you would be using this one right here if threads are excluded from shear plane. But once again, stated in this problem that the threads are excluded. So if they are to be excluded, ito yung gagamitin nating parameter ngayon, which is this one right here. So the first thing that we would be doing here is to list down the parameters. So for your Fy and your Fu, so it is stated here that we are to use A36 specification. So alam nyo naman na kung ano yung A36, it would be this one right here. So A36, so it would be this one right here. So its Fy and Fu respectively is to be 36 and 58. So 36 kips per square inch and 58 kips per square inch. And for the shear strength of the bolt, so FNV, this is to be equal to, so going back to this once again, so this is to be your FNV. So ito yung nominal shear stress in bearing type connection. So 457. So this is to be 457 megapascals. So the first thing that we would be doing here is to convert our Fy and Fu in terms of megapascal. So times 6.895 for our conversion factor. And this is to be equal to, so looking at the calculator to your left, so 36 times 6.895, that is to be equal to 248. So i-round na natin, no? So 248 megapascals. And for your Fu, that is to be, so 58 times 6.895, so that is to be 400. Guys, confirmation, gumagana ba yung calculator ko sa screen nyo?
Yes, sir.
Okay,
Yes,
so
sir.
thank you. So yan, very good. So next, ano ba yung kailangan natin gawin dito? So we must check if it would fail on the manner that we will be anticipating. Kasi nga ang hinahanap natin dito is design strength and the allowable strength. So by the way guys, when we say design strength once again, this is to be in terms of LRFD. And when we say allowable strength, this is to be for ASD. So ASD, LRFD lang siya. So baka nagsasawa na kayo. Anyway, so ano ba yung mga manner of failure na dapat nating i-anticipate? So since this one right here is a tensile member or a tension member, we must anticipate cross-sectional yielding, so GSY. We must also anticipate tensile rupture stress. Then for the connections, we must anticipate bearing. So check natin yung bearing strength niya. And yung shear strength din ng bolts. So both of these parameters right here are for the bolts. And this one right here are for your members. So ulitin ko lang, GSY ang ating isa-solve muna, no? And for your cross-sectional yielding, your PN is equal to Fy times Ag. So wala naman ang dispute dyan. You already know that. So for your Fy, it is stated in this slide right here that our Fy is to be, copy-paste ko na lang para hindi na ako mag-isip-isip pa. So it would be this one right here. So for our Fy, that is to be 248 megapascals times the cross-sectional area. So as you can see here, these are to be in terms of inches. So convert pala muna natin, no? So 1/2 inch is to be equal to, so converting it with our calculator. So 25.4 divided by 2, that is to be 12.7 millimeters. 12.7 mm. And this length right here, this width right here, which is 12 inches, that is to be equal to, so 12 inches times 25.4, that is to be equal to 304.8. So meaning for us to get the cross-sectional area here, that is to be equal to width times thickness, which is 304.8 times thickness, which is 12.7 mm. So, ayan. So, solving for this value right here, this is to be equal to, so, 248 times 304.8 times 12.7, that is to be equal to 959998.08 newtons. But since I want it to be in terms of kilonewton, so divide natin to by 1,000. So this is to be from Newton to kilonewtons. So divide na natin by 1,000. So dividing this by 1,000, we would be arriving at an answer of, round na natin, 960 kilonewtons. So 960 kilonewtons. So this is to be our nominal strength for our cross-sectional yielding. So, sunod pa guys?
Yes, sir.
How about for the
Yes,
others?
sir.
Okay, so
Yes,
ayan. So for LRFD, so LRFD RPU is equal to PN. And our phi in yielding is to be equal to 0.9. So same lang siya dati, no, sa analysis of tension members. So this is now to be equal to 0.9 times 960. So 0.9 times 960, and that is to be equal to 864. So 864 kilonewton. So this is for LRFD. And for ASD, so ASD, our our omega here is to be equal to 1.67. And from that, our PA is to be equal to PN divided by omega. And from that, our PA is now to be equal to, so ang PN natin once again is to be 960. Dividing it by 1.67, it would be giving us an answer of 574.85. So 574.85 kilonewton. So these are to be your PU and PA for cross-sectional yielding. So same lang siya sa prelims, sa midterms, no? So ayun. So next up, let's solve for tensile rupture strength or tensile rupture stress. So from that, our PN is to be equal to the ultimate stress FU times your effective area. So copy-paste ko lang muna ulit itong picture na to para hindi tayo mahirapan, no? So lagay natin dyan. So FU times AE. But AE, guys, is actually equal to U times area net. And as you can see in this setup right here, if we would be looking at this table right here, which is to be the value for your shear lag factor U. So sabi dito sa case number 1, all tension members where the tension load is transmitted directly to each of the cross-sectional elements by fasteners or welds. So as you can see, this is just to be a plate. Wala naman siyang legs, no, kasi hindi siya angle. So meaning the bolts, the loads are transferred to each of the members. So meaning ang ating shear lag factor is to be equal to 1.0. So for the area of, for the net area of it, that is to be equal to, so etong net area is to be equal to the cross-sectional area of your bolt minus the area of the holes, which is this portion right here. Ano daw pala yung gagamitin nating holes? So by the way, the bolts are 22 mm, A325 bolts. So, since we are to use standard sizes, ito standard size daw yan, looking at this table right here, pag gumamit daw tayo ng 22, pag gumamit daw tayo ng 22 dito, ang standard diameter daw natin is to be 24 mm. So, that is to be your nominal hole. So, nominal hole is to be equal to 24 mm. But according to NSCP, once again, we would be adding another 2. So, effective hole is to be equal to, so 24 mm plus 2, that is to be 26 mm. So, once again, this is to be the same procedure as when we have discussed about the analysis of tension members. Are you guys still following?
Yes, sir.
Okay, very good. So, ayan. So, once again, ang gagamitin daw nating holes is to be 26 mm. So, solving for our PN here, this is to be equal to FU times AE, and our FU is 400 megapascal. Ito, 400 megapascal. So, 400 megapascals times U. Ang U natin is to be 1.0 times area net. And our area net is once again equal to AG minus area of the holes. And from this one right here, ang AG natin is to be 304.8 times 12.7. So that is to be, so 304.8 times 12.7. So this is to be the cross-sectional area minus the area of the holes. So ang area natin ng holes is to be, ano ulit yung hole diameter natin? 26 mm. So 26 mm, which is to be this one right here. So 26 mm times the thickness of the plate. So the thickness of the plate here is to be 1/2 inch, and that is to be equal to 12.7 mm. And since we have two holes right here, times 2. So, kasi meron tayong dalawang balls yan. Kasi yung ating kino-consider dito na area is to be the area of this one right here. Then, tanggalin lang natin yung hole. So, ayun lang naman yun. So, solving for this one right here would give you an answer of, so 400 times 1 times 304.8 times 12.7 minus 26 times 12.7 times 2. So from that, we would be arriving at an answer of 1284224 newtons. But dividing this once again by 1,000 to arrive at an answer in kilonewtons. So divided by 1,000, our answer here is now to be equal to 1284.224 kilonewtons, or 22 kilonewtons na lang. So this is to be our PN. So erasing this ones right here. So ito na nga yung ating PN, ano? So for our value for your PU, palitan natin. So LRFD. So PU is equal to PPN. And phi in tensile rupture stress is to be equal to 0.75. So our PU is now to be equal to, so 1284.224 times 0.75, that is to be equal to 963.168 kilonewtons. And for ASD, so ASD, that is to be, so PA is to be equal to PN over safety factor omega, where your safety factor omega is to be equal to 2. So meaning, our PA is now to be equal to, so looking at the calculator to your left, that is to be 1284.22 divided by 2. 642.11 kilonewtons. So this is to be your ASD and LRFD strengths of your cross-sectional yielding and your tensile rupture stress. So are you guys still following? Review lang to from your midterms.
Yes, sir.
Yes, sir.
Okay, very good. How about for the others? Miss Kalob and company.
Yes, sir.
Okay, very good. O yung iba, okay naman. Proceed na tayo. Confirmation, guys. Proceed na tayo.
Proceed, sir.
Very good. So, ayan. Ito na yung bago. Very good. Ito na yung bago sa ating lesson. So, we have here our bearing. So, number 3. Palitan natin ng yellow. So, number 3. Bearing. As stated in the problem, deformation at bolt holes are a design consideration. So, meaning we would be using this one right here. Kaya ngayon, kinapipis ko yung formula in this part right here. So, Rn is to be equal to 1.2 times LC. But by the way, guys, ano mga ba itong LC natin na ito? So, this LC right here is either to be this distance right here. Teka, ba't nawala? N. Is to be this distance right here or this distance right here. LC and LC. Whichever is smaller. Kuha, guys? Kuha ni LC?
Yes, sir.
Yes, sir. Gets po.
Yes, sir.
Okay, so yan. Solve ngayon
Yes,
natin
sir.
kung ano yung LC. So, very good. Teka, baba natin onte para may space tayo. So for this one right here, solve muna natin to. So LC. So this is to be equal to, so sabi dito center to center spacing daw niya is to be 3 inches. But we have holes here. So this is to be the LC, 3 inches minus yung bolt diameter nito. Itong part na to and itong part na to or yung hole diameter. Okay, so this is now to be equal to, so 3 inches times, convert muna natin pala sa mm. So 3 inches times 25.4. This is now to be equal to, so using the calculator once again, so 3 times 25.4. So 76.2 dapat to, yun 76.2. So ito dapat 76.2 minus, so minus 26 times 2 over 2. So bakit times 2 over 2? Kasi, I mean, dapat yan, 26 divided by 2 times 2. Kasi itong part na to is just to be half of 26, which is 13. And this one right here is to be 13. So, yun, 26 over 2 yun. So, i-times 2 ulit natin, so babalik siya dyan. And our LC na here is to be equal to, so 76.2 minus 26 times 2 divided by 2, that is to be equal to 50.2. So 50.2 mm. So ito yung nandito sa part na to. And how about for the other part, which is to be at this point up until this point? So iurong ko lang to, guys. So for your, sabi natin LC2. So for LC2, that is to be equal to, so 3 inches minus 1/2 of this diameter. So that is to be equal to 76.2 minus, urong ko lang ulit, baka hindi nyo na makita ulit. 76.2 minus 26 over 2. This time wala nang times 2 kasi iisa lang, oh. Hanggang dito na siya sa dulo. And your answer here, ang late naman ng space. Teka guys, ayusin ko lang. Erase na lang natin mamaya. So the answer here is to be equal to 76.2 minus 26 over 2. And our answer here is to be 63.2. And as you can see in both of these values right here, that this value right here is much less than that of this value right here. So meaning, ito yung ating mag-govern na factor. So deleting this. So this is to be our LC. So our LC is to be this. So 50.2 mm. So ayan yung LC natin. So 1.2 times LC, tas meron pa tayong T dito. So your T is to be the thickness of your plate. So the thickness of your plate is to be equal to 1/2 inch or 12.7 mm. So times 12.7 mm. Then times FU, so 400 MPa. So there. So moving this just for us to have space. I mean, moving this one right here at the bottom part. I need space. So ayan. So we would be comparing it with this value right here. So it must be less than or equal to 2.4 times DTU. I mean DTFU. So ang D natin this time is to be the diameter of the bolt. So diameter of the bolt. Ano ba yung diameter ng bolt na natin? Kalimutan ko. So 22 mm pala. Guys, bolt pala to, ah. Bolt, hindi hole. So the diameter of the bolt is to be equal to 22 mm times the thickness, and the thickness of the member once again is to be 12.7 mm. Then multiplying it by FU, that is to be equal to 400 megapascals. So our Rn right now is to be equal to, so looking at the calculator to your left. By the way, guys, gumagana ba yung calculator sa left nyo?
Yes, sir.
Yes,
Okay.
sir.
So, ayan. Thank you. So, yan.
Yes,
12.2
sir.
times 50.2 times 12.7 times 400. That is to be equal to, sagot dito, 306,019.2. Sige. Newtons muna natin. 306,019.2 newtons. And let's check if it is to be less than or equal to this value right here. So, ano ba yung value na yan? That is to be 2.4 times 2.2. Ay, 22 pala. 2.4 times 22 times 12.7 times 400, and that is to be equal to 268,224. So, 268,224 newtons. And as you can see here, guys, that this value right here is less than this value right here. So, meaning this is to be our governing value. So, our Rn is now to be equal to, so 268,224 newtons. But take note, guys, that this answer right here or this value right here is only true for 1 volt. So, pang isang volt lang siya. So, as you can see here, we have, palakin ko lang ulit. So, as you can see here in this picture right here, we have 4 volts. So, 1, 2, 3, 4. So, for us to get the its strength, we must multiply this one right here by 4. And since it is in newtons, pagsabay na natin, convert na din natin into kilonewton. So, times 1 over 1,000 newton. So, 1 kilonewton per 1,000 newton. So, solving for this value would give you an answer of Rn to be equal to 268,224 times 4 divided by 1,000. This is to be 1,072.896 kilonewton. So, this is to be for your nominal strength of the bolted system. Then, copying this one right here at the next slide. So, copy lang natin. No? Ito yung pang-bearing natin. And now, let's solve for its LRFD and ASD parts. So, for LRFD, so our phi here is to be in terms of 0.75. So, ito yung gagamitin natin for bearing ng bolts. So, 0.75. So, our strength in LRFD is equal to phi Rn. And this is to be equal to, so ano Rn natin? 1072.896. So, multiply natin siya ngayon ng 0.75. Our answer here is to be 804.67. So, 804.67 kilonewton. So, this is for LRFD. And for ASD, so same old. If your phi is to be equal to 0.75, meaning that your omega is to be equal to 2.00. So, from that, your Rn over omega is to be equal to, so, 1072.896 divided by 2. So, that is to be equal to 536.448. So, 536.448 kilonewtons. And guys, di ko alam kung naituro ko sa inyo to dati. If you would be multiplying your phi to your omega, your answer should be equal to 1.5. So, as you can see here, 0.75 tapos 2. Kapag minumultiply mo sila, 0.75 times 2, dapat 1.5 yan, as you can see in the calculator to your left. So, going back to this cross-sectional yielding here, kapag yung phi natin is 0.9, so 0.9, if we would be multiplying it by this one right here, 1.67, so times 1.67, that is 1.5. So, for pretend na nakalimutan nyo kung ano yung value of omega pero naalala nyo yung value ng phi, pwede kayong mag-back solve using 1.5. So, are you guys getting my point?
Yes, sir.
Yes, sir.
Okay, so ayan. So, dapat product nilang dalawa is 1.5. So, once again, these are to be the bearing strength of our connection. So, na-solve na natin yung ating cross-sectional yielding, tensile rupture strength, tensile rupture stress, yung ating bearing, and lastly, we would be solving for the shear. So, dito ulit tayo. So, shear. Palitan natin. Yellow dapat. So, shear. So yung shear natin, I mean yung pag-solve ng shear natin is fairly similar to what we have been doing in the mechanics of deformable bodies or your strength of materials. So yun lang yun. So for your Rn, that is to be equal to your stress or your FNV, kung ano yung stress ng bolts nyo, times the shear area. Basta shear area dapat itong ATB na to. So if I am to copy this picture right here once again, so pasting it here. So ayan, as you can see guys, that we have 4 shear plane areas. Teka lang, ayusin ko lang. So as you can see, ito no, sa isang line, we would be having 2 areas, 2 shear areas, then meron din tayo dito. So kumbaga 4 yung ating shear areas. Do you guys follow? 4 yung shear areas natin?
Yes, sir.
Okay,
Yes,
so
sir.
ayan, we have our 4 shear areas. So I'm sorry at medyo lumalakas yung ulan dito, kaya ewan ko kung malinaw pa yung pagsasalita ko. Ilapit ko na nabibig ko sa aking microphone. So ayan. So solving for this one right here by direct substitution. So Rn, yellow dapat. So Rn is equal to, so what is to be our FNV? So kinuha na natin yan kanina. Our FNV is to be equal to 457 megapascals. So 457. So 457 megapascals. And for the area of the shear, so the shear area, that is to be equal to, so ano ba yung area ng bilog? Pi over 4 times diameter squared. And the diameter of the bolt is to be equal to 22. Guys, diameter ng bolt to, hindi diameter ng hole. So 22, not 26. So 22 squared. And ano pa ba? As you can see, we have here for shear area. So we would be multiplying this by 4 once again. So ito, isang bolt lang to, and we would be multiplying it by 4 kasi 4 nga yung ating shear area. So times 4. So from that, we would be arriving at an answer of 457 times pi. Asan na yung pi sa calculator na to? So shift pi divided by 4 times 22 squared. Wait lang guys, naghang yung aking calculator. Ayun, okay. 22 squared times 4. So our answer here is to be equal to 694,882. So 694,882 newtons. So converting this to kilonewtons, so dividing this by 1,000, you would be arriving at an answer of 694.882 kilonewton. So that is for our Rn. So for our LRFD, same old. Your PU is to be equal to VPN, and the value for your phi is also to be equal to 0.75. So memorize nyo to, 0.75 pag shear and pag bearing ng ating bolts. So there, and from that, your PU is now to be equal to, so dividing this by 1,000, so 694.883, 883 pala to, 883. 694.883. Okay, wait lang. So 694.883 times 0.75 would give you an answer of 521.16. So 521.16 kilonewton. So this is to be for your PU. And for your ASD, same old, yung inyong omega is to be equal to 2. And your PA is to be equal to PN divided by omega. And from that, your PA is now to be equal to, so 694.883 divided by 2, that is to be equal to 347.4415. So 347.442 kung na lang, 442 kilonewtons. So this is to be your PU and your PA respectively. So ang tanong, tapos na ba tayo? Basically, hindi pa, since hindi pa natin alam kung ano na-govern. So what I would be doing next is that I would be summarizing it. So dito, summary. So I would just be copying every value, no? So from our GSY, copy paste ko na lang. So what you would be doing next is to get the smallest value. So whatever the smallest value is to be the strength of your connection. So ito, ano ba yun? So dito sa LRFD, this is the one that would govern. So ito yung nag-govern sa ating LRFD. So this is to be your design strength. And for your ASD, it is also this one right here that has governed, which is for your shear. So basically, yan na yung ating final answer for this particular question, which is to determine the design strength and the allowable strength. So are you guys following? Naintindihan naman yung example natin?
Yes, sir.
Very good. Take note, guys, that if you would be having a certain connection like this, so as you can see, butt joint siya, no? As you can see also that you would be having two shear areas right here. So ito, may shear area ka dito, shear area, shear area, shear area. By the way, 4 pala. So for pretend na hindi ito yung setup natin, for example that your setup for this particular, tayo bumaba, okay. For this particular setup right here is to be a double shear area or a butt joint. So meaning that if you would be solving for your shear area here, instead of multiplying it by times 4, magiging times 8 na siya. So why is that the case? Kasi dito, meron nga tayong 4 na bolts. But for every bolt that you have, you would be having 2 shear areas. Okay, any questions, guys?
None, sir.
Okay. Okay, very good. So, ayun. So, I would be ending the meeting right now. So, lumagpas din pala tayo ng 1 hour. Sabi ko, dapat less than 1 hour.